Right, you're welcome to today's class. So we're going to look at calculations on waves, okay? So yesterday we actually did some terms used in describing waves, but today we are going to look at waves, then the calculation used in waves, okay? So let's go. All right, so we're going to look at the relationship connecting the frequency, wavelength, and the speed of the wave. And that relationship is what? All right, let's solve. A radio station broadcasts at a frequency of 300 kilohertz if the speed of the wave is 3 times 10 raised to the power 8 meters per second. Calculate the period and wavelength of the speed. And wavelength of the what? Let me see. Wavelength of the wave, sorry. Okay. Now, looking at this question, we have the frequency to be 300 kilohertz. What is kilo? Kilo is 300 times 1000 hertz, right? Now, what is the speed? Okay. All right. Now, for us to get the wavelength, we can use this formula V is equal to F what? Lambda, right? And for us to get the period, we can say this is 1 over what? F. Okay? Now, substituting into what we have that V is equal to this, right? So, let's go by saying that V is equal to 3 times 10 raised to the power 8. Okay? Now I'm going to just substitute into what we have. So my V is 3 times 10 raised to power 8 is equal to F is what? This is 300 times 1000, right? That is 10 raised to power 5. So we say times 10 raised to the power of what? 5 times lambda, okay? So I divide both sides by the coefficient of lambda, which is what? 3 times 10 raised to the power 5, right? If I cancel this, now this is going to be what? Okay, divided by, is that clear? So this can cancel this. I have lambda is equal to 1 times, this is 10 power 8 minus 5, which is 1 times 10 raised to the power what? 3 meters. Is that clear? All right, so coming to the period, remember that period is inverse of frequency. Simply, we are going to say that f is equal t is equal to 1 over f. That is 1 over what? 3 raised to the power of 5. So this is 3 times 10 raised to the power what? 5. Now we can use our calculator to do that, right? So let's see what we'll have. So I'm going to have 3.3 times 10 raised to the power minus 6 seconds. Do you understand? So this is how we can solve such problem concerning waves. So put it down, let's proceed. All right, so let's solve another one. All right, so let's look at this second example. The period of a wave is 0.02 seconds. Calculate its wavelength if its speed is 330 meters per second. Now, let's solve. Our period is given as 0.02 second, okay? Now I have to find the wavelength, and we're given the speed, which is 330 meters per second. So what you're going to do now is to get our frequency, knowing that frequency is 1 over what? Period. So you're going to say 1 over 0.02. Okay? Now let's see what we'll have. We have our calculator, is going to give us 50. Now this is 50 Hz, right? Okay, now for us to get the wavelength, we're going to use this formula. I said that V is equal to F what? Lambda, okay? So what's my V? I have 330 is equals to, my frequency is 50 multiplied by what? Lambda. So just divide both sides by 50. Okay? And by the time you cancel this, you can say therefore lambda is equals to 330 over 50, right? So we get again by saying 330 divided by 50. My answer becomes 6.6 meters. I hope that is clear. All right, put it down. Then you go, my, you're welcome. Please copy what we have on the board. Let's proceed. If you are done, you just let me know. Let's solve more examples so we can end the class, okay? All right, so let's solve another example, okay? Okay, so let's look at this. The wavelength of a wave traveling with a second is 60 meters. The period of the wave is what? Now, let's take the parameters we have. We have that the velocity is giving us 360 meters per second. We have that the wavelength is giving us 60 meters, right? We are looking for the period of the wave. Now, what do we do? We said that what? We must convert this to meters by saying that this is 60 over 100, because to convert centimeter to meter, divide by 100. So we cancel this. We have 0.6 meters. Okay. Now we cannot find the period without looking for the frequency, because both of them have relationship. Okay. All right. So knowing that V is equal to F what? Lambda. But because that F is equal to 1 over T, we can still substitute it into this equation to have that V is equal to lambda over T, right? It is still correct. Now, we can do cross multiply. T is equal to lambda over what? The speed. Now, what is my lambda? Is given as 0.6 meters. We have 0.6 over, my speed is what? 360, right? Now, by the time you divide, you're going to have what? Let's use our calculator to get our answer. So I'm going to have 1.67 times 10 raised to the minus 3 seconds. Okay? So my period T is given as 1.67 times 10 raised to the minus 3 seconds. Do you understand? So this is how to solve this type of problem. I hope that is clear. All right. Onyema, you're welcome. Please, do you understand what I just explained? Do you understand? Should we solve more problems? Because I want to drop classwork now. Okay, I should explain again. All right. The question says, if the wavelength of a wave traveling with a velocity of 360 meters per second is 60 centimeters, the period of the wave is what? Now, from what we have in this question, we are given the velocity as 360 meters per second, and we are given the wavelength as 60 centimeters. But we need to convert this to meters simply by dividing by what? 100. So if you divide this by 100, it's going to give us what? This cancels this to give us 0.6 meters. Okay? Now, we are looking for the period actually, but the formula we are using is V is equals to F lambda. All right? Now, knowing that F is equals to 1 over T, that's from the relationship, we can just put it here and the equation will change. Now, it's going to be what? V is equals to F multiplied by T, which is when you apply this formula, okay? Now, doing cross multiply, we have that period is equals to lambda over what? The velocity. I will just substitute into what I have. My wavelength is 0.6 and my what? My speed is 360. Okay, so by the time you divide, you're going to have 1.67 times 10 per minus 3 seconds. That becomes the answer. All right. Yeah, are you cleared? Yeah, do you understand now? Yeah, my gifts, are you there? Now let me give you what you're going to. So let me give you just one example to try, okay? So we can end the class. It's just 1 hour class. All right, so you can attempt this as Tenny Goma. My gift. So you can attempt this question and drop your answer, okay? Let's see if you understand better. Okay, I'm waiting for your answer, okay? And 1,000 hays. Okay. All right. Then you go, might have 1,000 hays. Gives you have 1,000 hays. So let's solve. Okay, so a wave of wavelength 0.3 meters. So the wavelength is 0.3 meters. Okay. All right. It travels 900 meters in 3 seconds. So the distance it traveled is 900 meters. And time is 3 seconds. We're looking for what? Frequency. V is equals to F lambda, right? Now we don't even have velocity. We must get velocity before we can talk about the frequency. Velocity is equals to distance over time, right? So let us get the velocity. What's my distance? My distance is what? 900 divided by time is what? 3. Okay? Now by the time I divide it, I'm going to have 300. So this becomes 300 meters per what? Seconds, right? So is to get our frequency using the formula V is equals to F what? Lambda. So my V is 300 is equals to my F is what? Is what I'm looking for, and my lambda is 0.3. So this is 0.3. So I'll divide by 0.3, 0.3. Okay. So now my frequency is equals to 300 over 0.3, and which will give rise to what? 1000 Hz. Okay, so you guys are correct. So the answer to this question is 1000 Hz. Atosape, you're welcome. All right, so I'm going to give you assignment that are going to solve, and you drop your answer in the comment section. Okay. All right, so just copy what you have on the board as the assignment. Let me know when you are done so I can end the class. Please make sure you subscribe to this channel, okay? And give it a thumbs up. Make sure you subscribe to this channel. So are you done? Are you done copying the assignment? All right, Tonya, I've already gotten your answer. Your speed is 36 meters per second, and your frequency as 54.217 Hz. All right, so we'll solve that one later. That is an assignment. You're going to check whether they are correct or not, but that will not be today. Clifford, you're welcome. You're just coming now. So late. Okay, you can watch the video after now. Then you will soon end the class. Then you go back. Make sure you subscribe to this channel. Clifford, or have you subscribed to this channel? And Onyema. All right. So I'll be posting on the group the time for tomorrow. Since tomorrow is Sunday, I'll post the time we're going to have class tomorrow. Yes, there will be class. I'll post the time on the platform. To be in the afternoon, not by 11, so I can go to church and come back. Okay? It's just 1 hour now. All right, so I've come to the end of today's class, okay? I will tell you the time for tomorrow's class. So make sure I do your assignment, all right? Okay, so bye for now.